Welcome friends. In this video we are going to look at the science paper 1 for the year 2023, and this paper was written by the external candidates. Now here we are going to focus on section A. So section A consists of 4 multiple choices. From those 4 multiple choices, you are required to choose the one that you think is correct. Now it's not for you to run to the multiple choices. So what you need to do is you need to look at first you need to find the answer, then you compare from the multiple choices which one is corresponding to your correct answer. Now the first one here, we have the following diagram shows a vernier caliper with its jaws closed. So whenever we have the jaws closed, we are trying to find what we call the zero error. So how do we find the zero error? So that's our focus for this question. Zero error can be found like this. So now I want us first to look at how do you know that there is zero error or no zero error. So let's have another diagram. We have the main scale here, then the vernier scale here. If the 0 on the main scale coincide with the 0 on the vernier scale, if we have 0 here and also another 0 here, then the other readings like this, then we can conclude by saying no zero errors. Whenever the 0 from the main scale coincide with the 0 from the vernier scale, the conclusion is that there is no zero error. So that is what you need to look at whenever you want to determine whether there is a zero error or no zero error. Now, away from that, we can have a positive zero error or a negative zero error. So if we have this situation, if the zero of the vernier scale is to the left of the 0 of the main scale, then we are going to have the negative zero error. Now for the case that we have here, we can see that this 0 is to the right of the main scale, so we are going to have a positive zero error. Now how do we find this positive zero error? So you do this. So we need to look at we are going to count from 0 up to this point where there is this line coinciding with the main scale and the vernier scale. So we can see that it's this line here. This is the line that is coinciding. So this is the point that you need to focus on. Now, what position is this line? So it is on position number 3 because this is 0, 1, 2, 3. 3, whatever number that line is, you multiply by 0.01 centimeter. This will give us 0.03 centimeter. So this is how we can find the zero error. So we have our answer B. We move on to question 2. 4 objects E, F, G, and H of different masses were placed at different places with different gravitational field strength. Which object has the largest weight? How can we find or determine? So we can't just rush to the answers looking at the numbers. We are going to find weight for each individual objects. We begin with this one. We know that weight is equal to mass times gravity. So what's our mass for this one? It's 8 times 10.4. So 8 times 10.4, I'm getting 83.2. What of the second one? This one will be 8.5 times the gravity is 9.8. 8.5 times 9.8. I'm getting 83.3. Let's try this one. 9.0 times 10.2. So I'm getting I'm getting 91 according to my calculator. So 91.8. Okay, for the last one, it's 9.5 times 9.5. So my final answer is 90.25. We can now conclude that the final answer is C, because we have seen that 91.8 is of the greatest in terms of the weight. So let's move on to question 3. A coconut drops from the top of a palm tree 20 meters high. If air resistance is neglected, how long will it take the coconut to reach the ground? So whenever we have the question of how long, it is asking us to find the time that was elapsed. So how can we find that time? Let's see if we can have a picture. This palm tree has a height of 20 meters. 20 meters. This height can also be represented as the displacement, which is x. In some textbooks you may find it as s. Then what else do we have? We have the gravity, which is the acceleration due to gravity. We have it. The acceleration due to gravity, we have it 10 newtons per second, which is same as 10 meters per second squared. What else do we have? We also have the initial velocity. Where are we getting the initial velocity? From the word drops. Whenever we have drops, the initial velocity is what? 0. Then we need to apply the 4 equations of motion. From there, we'll look at the one that is applicable. The first one, we have final velocity is equal to initial plus acceleration times t. The second one, we have displacement is equal to initial plus v times t over 2. The third one, displacement is equal to initial times t plus acceleration of at squared. The fourth one is final velocity, which is squared, is equal to initial squared plus 2 times acceleration times displacement. Now, if we had to collect the data will be here. So we have SUVAT. So from the word SUVAT, S is for displacement. We have it 20 meters, which is the same as height. Initial is 0. Then the final velocity we don't have, so we just put a question mark. Acceleration is 10. Time we don't have. So the question is we want to find time. So we need to choose the equation where we have time, but we do not have the final velocity. So this one is not applicable. We don't have time. Then among the other 3, this one is the right formula. Why? Because there is t, the one that we are solving for, and there is no v. After choosing the formula, we can now put the work into calculations. So S is equal to ut plus half at squared. Now, whenever the initial is 0, this can be cancelled, because if you put where there is 0 times t, anything multiplied by 0, we still have just 0. So this formula can be simplified as height for this one, since the displacement is given as height. So height is equal to half at squared. Now A is for acceleration due to gravity, so we can say gt squared. So what's our height? So our height is 20. Acceleration due to gravity is 10 times t squared. 2 here is 1, 2 here is 5, 5 times t is 5t squared. We divide by 5, t squared is equal to 4. We take the square root, t is equal to plus or minus 2. Therefore, the final answer is positive 2 seconds. We can't have a negative time. So that's how we can find the answer now. So our final answer is A here. We move on to question 4. The following diagram shows a uniform meter rule in equilibrium when different masses are hung on either side. On the left side, we have two moments, the one with 10 grams and the other one with 20 grams. So how can we find the value of x? So x represents the mass that we can multiply by 40 to equate to the moment on the left side. So let's find these two individual moments on the left side. So say moment is equal to, we know that it's force times distance. Now since we are dealing with mass, we'll just say mass times the distance. Remember, the distance is always considered from the pivot. So the pivot is here. This is our pivot. So the distance from here up to here will be the distance for 10 grams. So 10 times, so what you do, 30 plus 10, we get 40. So 40 times 10 is 400 grams centimeters. So this is the moment for this one. Let's also find another moment for 20 grams. Moment is equal to mass times distance. Mass is 20 grams. Then the distance from here up to here is 10 centimeters. This will give us 20 times 10 will give us 200 grams centimeters. So the total moment on the left side will be 400 grams centimeters plus 200 grams centimeters, which is equal to 600 grams centimeters. So we have the total moment on the other side. Now let's find on this side. So x represents the number that we can multiply by 40 to give us 600. So how can we find this number? It's as simple. So you get this 40, you divide into 600. So 600 divided by 40. We know that this centimeter, this will cancel, this. So 4 into 60 is 15. So the answer is just 15. Or you can use the moment formula where you equate, you still get the same answer. We move on to question 5. A bullet passes through a wooden block 0.8 meters thick. The velocity of a bullet reduces from 700 meters per second to 300 meters per second as it passes through the block. If the mass of the bullet is 10 grams, calculate the work done by the bullet in kilojoules. So the movement is in x-axis. So how can we find the work done? We know that work done is equal to force times distance. Now we don't have the force, though we have the thickness. So now how can we find this? We need to use the formula for kinetic energy, which is given by, now we'll say work done is equal to half mv v squared. Remember, the mass must be in kg, so we need to divide by 1000 to make it kg. So 10 divided by 1000, I'm getting 0.01. We need to find the velocity. The initial velocity is this number 700, the final is this one, so we need to find the difference. 700 minus 300, so the difference is 400, which, whether positive or negative, know that whenever we square that number we still get the positive. So we have 400 squared, which is 400 times 400, we are going to get 160. So half times 0.01 times 160,000. 160,000 times 0.01 divided by 2. I'm getting 800 joules. Remember, the question is we need to give our answer in kilojoules. So how do we convert joules into kilojoules? You divide by 1000. Remember, kilo means 1000. 800 divided by 1000 will get 0.8 kilojoules. Our answer is A. Question 6. An elevator ascends at a constant speed of 1 meter per second. The total mass of the elevator is 1000 kilojoules. Take gravity is equal to 10. Can get the power required to raise it to this speed. Power is equal to work done over time. Work done, for this one, we are looking at the work done against gravity. So we use the formula for potential energy since we are given mass and the height. So mgh, mass is this number 1000 times gravity is 10 times what's the distance? So the distance is 1 meter, so times 1, which is this one is giving us 10,000 joules. So the work done is this number 10,000 joules over time. What's our time? We are told per second, so whenever we have per second, same as 1, which is same answer, 10,000 watts. So our answer is C. Question 7. The following diagram shows a pulley system. Okay, so let's have if a man using the pulley system pulls the rope at E 16 meters downward, how high will the load F rise? So let's find the velocity ratio. Velocity ratio for this one, you just have to count the number of ropes. 1, 2, 3, 4. The velocity ratio is equal to 4. Or if you want, you can just calculate these pulleys. 1, 2, 3, 4. So how can we use velocity ratio to find the distance moved by the load? The distance moved by the effort we are given, then the distance moved by the load is what we are calculating. So now how can we use the velocity ratio to find that? So the key point is, if you are given the distance moved by the effort and you are told to find the distance moved by the effort, you just have to divide distance moved by the load, by the effort, divided by the velocity ratio. So distance moved by load is equal to distance moved by effort over velocity ratio. Distance moved by effort is 16 meters over velocity ratio is 4. 4 into 16 is 4 meters. So answer is B. Question 8. What is the main reason why food is cooked faster in a pressure cooker than in an ordinary pot? A. It is not affected by the atmospheric air. B. Less heat escapes from the pot. So the answer is B. Pressure cooker is the cover or the lid is very tight. So as a result, the heat cannot escape the pot. 9. In a thermal flask, a vacuum reduces heat transfer. What method or methods of heat transfer is or are reduced by the use of vacuum? So vacuum can only reduce or prevent heat transfer by convection and conduction. Number 10. Which feature of a liquid in glass thermometer increases its sensitivity? The answer is A. Narrow capillary bore. 11. Which of the following diagrams shows the correct path of ray of white light passing through a glass prism? So now what happens when white light passes through a prism? So we are going to have the dispersion where we are going to have the rainbow colors. So from this diagram, the one that is correct is B. So the type of refraction that we have in the prism, the after light, this is a white light here. So after leaving this prism, we are expecting to have Roy GBV, where we look at the rainbow colors, but we only have one. So the type of bending that comes after this point is not in this direction, but we are expecting to have this kind of bending. Number 12, the following diagram shows a transverse wave. How many complete waves are shown in the diagram? So from here up to here, one wave. Here up to here, 2 waves. Here up to here, 3 waves. So the total is 3. 13. The following diagrams show 2 waveforms. Which property of sound wave is different in the 2 waves? So let's focus on what was different here. So the whole thing, it was about the amplitudes. This amplitude is greater than this amplitude. Which property of sound can be affected by amplitude is loudness. 14. Which statement is not true about a magnet? It is always A. Attracting magnetic material near it. Yes. B. Made from a magnetic material. Okay, let's first put a question mark here. C. Made up of 2 poles, 2 opposite poles. Yes. Resting in the north-south direction and expanded freely. Yes. So these to be honest, these are answers. They are all answers, but the one that we can go for is just this B. 15. Which diagram correctly represents results obtained when a charged gold leaf electroscope is brought close to a charged metal rod using the method shown? So before this positively charged rod is brought near to this gold leaf, the whole thing is neutral. There is no deflection. So now the diagram that can correspond to the information given above is B. Look at the nature. This has a negative charge. So the positive charge from the gold leaf will be attracted here. Then this will remain negative. There will be that repulsion between these and these. So as a result, this will deflect. So the answer is B. Number 16. The following diagram shows a cathode ray oscilloscopy, CRO, with a bright spot formed from an AC generator. Which part of the CRO brings the movement observed? Brings the movement observed. Brings the movement, see, the movement observed. So the Y plates and the X plates does the deflections. Cathode produces electrons. Anode accelerates the movement of electrons. So it's there to just increase the speed of the beam of electrons. So brings the movement observed. So the best answer here is D. Since the anode has a positive charge, electrons have the negative charge. So because of this, the electrons will be attracted. So because of that attraction, the electrons will move at a faster speed and observed on the fluorescent screen. Since the whole thing is about the movement. 17. Start the circuit diagram shown. Calculate the value of resistor X given the ammeter reading is 2.5. So we have so many ways in which we can solve for the value of X. Okay, let's look at the first one. We are going to find the total resistance of this circuit since we have the total current and total voltage. So resistor is equal to voltage over current. Voltage is 8, current is 2.5. 8 divided by 2.5. The total resistance for the whole circuit is 3.2 ohms. From this 3.2 ohms, we are going to subtract the one which was in series. 3.2 minus 2. We have the total resistance for these two in parallel of the value 1.2 ohms. Now, how can we find the missing given the total resistance and 1 for those two that are in parallel? So we use the formula RT is equal to R1 times R2 over R1 plus R2. Here we'll say R1, then here we'll say R2. Our total resistance for these two is 1.2. R1 is X times R2 is 2 over here R1 is X plus R2 is 2. So let's use algebra. We cross multiply here. 1.2 times X is 1.2X. Number 2, 1.2 times 2. I'm getting 2.4. Here we have X plus 2. So we are going to collect the like terms. 2.4 go this, then this one will go to this side. 1. So this should be 2x. Since it's x times 2. 1.2x minus 2x is equal to negative 2.4. So if we subtract, we get negative 0.8 is equal to negative 2.4. We divide by negative 0.8, also here negative 0.8, which is x is giving us the value of 3. So here the 3 ohms, so the answer is D. Or if you want, we can also find it like this. We know the total current is 2.5, so we can find the voltage that was used at this. So voltage is equal to current multiplied by resistance. So current is 2.5, resistance is 2. 2.5 times 2 will give us 5 volts. From 8 volts, 5 volts was used at this point. Here we are going to have 3 volts. So you subtract the one that is in series. We use a certain amount of voltage, which is the one that we have calculated. Here we are going to have 3 volts. In this direction, we are going to have 3 volts. Also in this direction, we are going to have 3 volts. Why? Voltage is equal whenever we have a parallel connection. Let's find the current on 2 ohms resistor on this one here. Voltage for this one is 3 over 2. 3 divided by 2 is 1.5 amps. From the 2.5, 1.5 went through this one. Here we have 1.5 amps. From this 2.5, let's take away 1.5. What are we going to have is 1 amp. So 1 amp went in this direction. Here we have 1 amp. Let's find the resistor here. Resistor is equal to voltage over current. Voltage here is 3 over current is 1. 1 into 3 is still 3. So we are still getting the same answer. Question 18. Start the following diagram. What name is given to the electrical device shown in the diagram? A. Alternating current generator. No. B. Direct current generator. C. Step down transformer. D. Step up. So let's look at the number of turns. So we can see that the number of turns on the primary are greater than the number of turns on the secondary. So this is a step down transformer. Number 19. Which radiation is used to increase the shelf life of fruits and vegetables? We are looking at the radiation that we can use if we want to conserve fruits and vegetables, or if we want to cook these for a longer period of time. We have gamma radiation. 20. The last one. Iodine is a radioactive substance with a half-life of 8 days. What fraction of iodine will remain after undergoing a series of disintegration for 32 days? So let's say we have 1. The first one, let's multiply by half. This will give us 1 over 2. First decay. Now, if we divide 8 into 32, we are going to see that we have 4 decays. Whatever substance, this iodine passed through 4 decays to reach to that. So the first decay is half times another half, which is 1 over 4. Second decay times another half, which is 1 over 8, times another half, which is 1 over 16. So first decay, second decay, third decay, fourth decay. The fraction is 1 over 16, which is C. So this is how we can answer this question. That's it for this video. Thanks for watching.